Alright, so hello and welcome. Here again with another problem. This one we'll do in Java as well. So I guess we'll get right into this problem. It's funny, I started the day very excited and like looking to try to do a lot of, I guess solve a lot of problems very quickly, and then I ended up just like getting completely stumped by the palindromic subsequences question and realizing that substrings question, realizing that there are quite a few competitive programming topics that I need to go learn, and yeah, I gotta go learn those things. I don't know when I'm gonna do that. I guess we'll solve another problem first. I guess we'll solve a problem, then after this we'll go review some questions. Given an integer num, you can swap 2 digits at most to get the maximum value number. Return the maximum value number you can get. So you swap 2 digits. Swap the number 2 and the number 7. No swap. So the way to do this, the number has 8 digits. Okay, this is a pretty easy one. All you got to do with this is you convert the. So that there's only 10 digits to begin with, but you convert the number into actually, this is kind of an interesting one. This might be harder than I realize, but well, okay. There are a few ways to think about this, but yeah, I think this is a relatively easy question. What you can do is you can brute force this by. Oh, you know what? Actually. Okay. Well, okay. Here's the first thing. The largest digit. If there are any digits that are larger than that digit, then swapping that digit with the largest digit, any of those larger digits will give you a larger number, and then swapping with the maximally largest number digit is ideal. So, and then if you have more than one of those maximally largest digits, you want to pick the one that's furthest to the right. In theory, yeah, because it's necessarily larger, right? Now there could be a few things here. The largest digit could be the first digit already, in which case you want to leave it alone. Actually, it's not as easy as I thought. Could be the largest digit already, in which case we'll come back to that. But if it's not the largest digit, then yeah, swapping with the rightmost largest digit, I think, is the first thing to do. So, yeah. Okay. So I think the first thing to do is take this number and break it up into its digits, and then we're going to rejoin those digits later as a number. The next number to swap, I think you basically perform the same subroutine again. You just do it twice. So, but you must consider all of the digits to the right. So, I guess we can use a map. There's only 10 digits, so we can use an array of 10 numbers and just keep track of the. We could process all 8 number. Yeah, there's only 8 numbers, right? All 8 digits. 10 to the 8th. I think maybe 9. Maybe 9 digits. Process all 9 digits, and is it less than or equal to? Okay, there could be 8 or 9. Process all 9 digits, and I mean, even if you do it a linear routine, 8 times, so it's quadratic, or even if you perform an algorithm that's quadratic in the number of digits, it's still extremely fast, right? It's only 64 iterations, 64 operations, or yeah, iterations, I guess. Or Yeah, we'll just say 64 iterations. So we can do quadratic time. That's fine. So the first routine is going to be take all the digits and find the smallest. It's going to be basically like a frequency map, but we're look not a frequency map, but a hash map. We're going to hash to each digit. We're going to hash into just a vector of integers or an array of integers, 10 integers. The first occurrence to the right where that digit occurs, and then what we're going to say is take the largest integer, or I guess there's some index. So we can make this like a subroutine that we run, so like a lambda function, lambda expression, and consider the digit at the index that we're looking at. If there is a larger value to swap this with, then we should do so. A larger digit, swap it with the least significant value. Now that's a good question, actually. Yeah, because if you swap it with the more significant value, that'll actually be a smaller number than the least significant. Correct. Yes. So swap with the least significant number, the largest number, and swap at the index where it occurs, the furthest to the right, and then so you do that, and then you're going to repeat that again for the next number. Increase your index to the next number. Now, if the first number there are no other larger digits to the right, then you skip and you perform the same routine but with the next index over. So basically, we're going to do one swap, or routine to do one swap from a given index. However, if we don't need to do a swap, then we'll try it on the next index, and you're going to repeat that process twice, and you might actually end up in a position where you don't perform any swaps. So this first swap, there are no smaller digits. There are no larger digits to the right. Are no larger digits to the right. Are no larger digits to the right. And again, no larger digits to the right. And that's that. And what do we want to return? An integer. Yeah. So I guess you just rebuild the integer at the end. So we can use a character array to do this. So this is not too bad. So swap subroutine. I think we can use an inner interface to define this. Let's actually make that a private method. I think in the case of Java, in some cases it can be better to actually just write your own function. Okay, so we'll do void swap, digit swap. We'll call it optimal digit swap or maximal digit swap. We're gonna have so it could be character array vals, or just digits, and target index, and we actually we should use digit. That's fine. Okay. So what we're going to do is I think we're going to have a list. We'll have you can do an integer array. That's fine. We know how many we need. So least position. It's going to be new int array of size 10, and we're going to loop for character C in digits. So it's actually I don't think you can do it that way. I is less than digits dot length plus I, C equals digits of I. And we'll say, so actually this needs to start out at target index -1, I is greater than or equal to 0, believe it or not, and decrement I. This is kind of a subtle thing. So we do this. Oops. Do we? We do. Okay. And how are we doing on time? 10 minutes. Okay. Decrement from left to right, digits of I. We are going to loop through our characters, and we'll say least position of. We could actually fill these with -1, really. Arrays dot fill. Least position -1, and we would say if least position. So actually, we don't even need a character. We can do int x is equal to digits of I -0. Now this is a tricky thing. You've got to convert this to a. So this is a character. We're going to convert this to an integer. Least position of x is equal to -1. Then we'll set least position to be equal to I. And actually, you want to go from right to left, I think. Yeah. How does this work? If you're going from left to right, then the least significant will be the last one you add. So actually, you don't need to do any of that. You can just set this here. Process digits to the left. Track of the least significant position for which a given digit appears. Okay. And then now determine whether a larger digit given 1. Actually, we can do Boolean. That's maybe better. Whether we actually swapped or not. A larger digit than the given one appears at all. At the target index. Appears at all. If so, perform a swap. Index. Otherwise, return true. Return false. Okay. So we can just loop backwards. Int I equals 10 or 9. I is greater than or equal to 0. Minus I. Actually can start at digits of target index -0 converted to an integer. Okay. And we say if least position of I is not equal to -1, then return true. Perform the swap, return true. Turn false. So we'll say int temp or character temp char temp is going to be equal to digits of say int next or swap target is going to be equal to the least position of I. And we're going to say digits of swap target. And we're going to say digits of swap target is then equal to digits of target index, the other target. So we'll just say swap index, call it that way, or express it that way. I think it's better than just calling that, yeah, another target. So swap index is going to be equal to, or actually, yeah, that's fine. And then we'll say digits of target index is then equal to temp. And we'll return true. So we swap these characters. We want to, yeah, so maximal digit swap. So we'll say int count equals 2, while count and so if maximal digit swap and we decrement the count, and we'll say count target equals, we'll start from the leftmost digit, which is actually, so we want to character, we'll just say digits is equal to, so we're going to take num dot to, so we can do string dot to string, or num dot to string dot to string dot to character array, and digits dot length -1, target is greater than 0, otherwise, so actually no matter what case we're going to decrement the target and also decrement the count. And we're going to say target and digits, and then process the integer as a character array, form add most 2 swaps as needed. In some cases, it's best as needed, beginning with the most significant digits. In some cases, skipped, or 2 swaps won't be necessary. Will be necessary, yeah. Or possible, maybe, yeah, necessary. Rebuild the integer from the digits array, character array. So if there are, see, here's the thing. This could be 10 to the 8th is kind of tricky. 10 to the 8th is okay. Times 9, right? This, I think, if we take this log 2. Oh, okay, we're fine. Never mind. we're going to rebuild the integer. So we're going to say ret is equal to, so we're going to, yeah, ret is equal to 10 times ret plus the digit, which is digits of I minus 0 as an integer. Okay. And the tricky thing about this is I did this wrong, actually. I calculated this wrong. How are we doing on time? Got, yeah, 20 minutes in. Okay. So the problem, there's a problem here too. I'll go over that in a second. But we want to start from the left. How are we going to make these digits? How are we doing this? And you convert this to the array. The most significant digit is on the left side. What even? Yeah. How do we? I think when you take a string, right? So the most significant digits are actually going to be on the left side, the smallest. That's interesting. Huh. Is that right? I think so. Yeah. Oh. Okay. Interesting. Yeah, well in that case, the most significant digit is on the left, which is actually, so this is kind of inverted, believe it or not. So actually, yeah, this would be the most significant digit. Okay. So that's confusing. Can reverse this string, I think. That's probably a good idea. Can we reverse strings in Java like that? Wow, why is it so hard to reverse a string in Java? Serious question. Why is this so difficult? It's not the first time I've looked this up, as you can see. All these people writing all these subroutines. That's really annoying. String builder. Oh, I see. Okay, you can use a string builder. Okay, fine. We're gonna reverse the string. Okay. Do we need to import a string builder? I think we don't need to. It's part of java.lang. Yeah. So that's why the least significant digits are the smallest indices. So we can kind of think about this in a way that sort of lines up with what's in my mind. It's in our minds. Presumably our minds, but my mind. It's in my mind. And then, okay, so least position. We're going to go left to right. Try to find any digit. These digits, we say, okay, so if least position of I, so these are all, so actually this should be starting from that digit really +1, and while we're less than or equal to 9, yeah, so if this is 9, then we just exit, right? If it's 8, so it should be, Yeah, I is always going to be greater than or equal to this. Increment I. So we want to start off, it's actually the other way around. We want to start off at I equals 9, and I is strictly greater than this value, target value. Whoops. We make the first swap. The first time we see something greater than target value, well, I is greater than target value, decrement I. If this value exists, then we return true, otherwise we break and return false. Okay. Form the swap as desired. Yeah, I wanted to get that correct as well. And then rebuilding this, so the least significant digit is going to be on the rightmost side. So we actually want to go from the most significant digit. So we want to go the other direction. Yeah, it's a bit tricky how to do this. Nice. Excuse me. Excuse me. All right. Let's give that a shot. Give that a shot. Okay, I see the problem. See the problem. Okay, how about this one? Okay. Okay. Ah, we were so close. We were so close. Alrighty. Okay. How are we doing? How about this? All right. Did we just do better? Did we just do better than what they're expecting? 2736 becomes 7236. Swap the number 2 and the number 7. Oh! Swap 2 digits at most. Oh, whoops. Whoops. We're only doing one swap. Excuse me. Excuse me. Excuse me. That's my mistake. Actually, if they're sorted from left to right, then the digits, then there's no swapping to be done. All right, what do we get for, hold on. 1, 2, 3, 4, 5, 6. I think we only have 9 digits there. Most 9 digits. Invalid test case. Oof. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. Alright. So this has got to be 9. More or less, yeah. Something like this. Alright. Let's go for it. Probably wrong somewhere, but let's go for it. Hey, we got it. Sweet. Alright. 31 minutes for this problem. Wow. 1 millisecond. Really? Really? Half of them are 1 millisecond. No! Come on. I can't get, that's fun. Okay. Oh no. Oh no. Well, you really only need to do this once then. Don't need a while loop. Let's try again. See if we can get 0 milliseconds. Hey, there we go. Alright, and then a little bit less memory. It's kind of just random. Alright, I mean that's kind of an easy question. I didn't realize I thought they wanted more than one swap. With just one swap. We could have done more than one swap, but yeah, just one swap would be just one call to this function. That took me a lot longer than I thought it would. I mean, that wasn't too bad, but I guess I had to look up a few things like the string builder and reversing the string, and it's good to remember that now also that you can use a string builder to reverse a string relatively easily. That's good. That's good. Convert the string to a string builder, reverse it, and convert it back to a string. It's a clean way of doing it. I think that's fine. Okay. All right. Thank you for watching. That one wasn't too interesting or too complicated. I guess it just is what it is, or is what it is, was what it was. I don't know what to say. That wasn't too bad. So yeah, thanks for watching. Talk to you soon. Take care.